So far we learned the production possibility curve using the production possibility schedule and the central problems. Now in this video number 4, we are going to learn about the opportunity cost. See, so far we learned that if an economy wishes to produce two types of goods, X and Y, then one has to forego some units of Y to produce more of X with the given set of resources. Now we learned certain assumptions that resources are constant, the technology should not be changed, and so on. So with the given resources, either we produce all of X or we produce all of Y, or if you want to produce more of X, then we have to sacrifice some units of good Y, isn't it? In this concept, let us learn about the opportunity cost. Now suppose you are offered two jobs, job 1 and job 2. Job 1 offers you 50,000 rupees per month and job 2 offers 80,000 rupees per month. Which one would you go for? Obviously job 2. So what is the opportunity cost of going for job 2? It is 50,000 rupees. What opportunity actually means is chance, or let us say a favorable circumstance, isn't it? So if the favorable circumstance is job 2, then we are foregoing an opportunity of job 1, which offers us 50,000. Now here we have two instances. So what is the opportunity cost of job 1? If you choose job 1, you are foregoing job 2, that is 80,000 rupees. So the opportunity cost of job 1 is 80,000 rupees. On the other hand, the opportunity cost of job 2, that means if you choose this, you forgo 50,000 rupees. So the opportunity cost of job 2 is 50,000 rupees. Let us say you have another offer of job 3 which offers 75,000 rupees. Then what is the opportunity cost of job 2? Is it 50,000 or 75,000? It will be 75,000 because this 75,000 is the next best alternative. If you choose for job 2, then you have 50,000 here and 75,000 here. Which is the best alternative? 75,000. So the opportunity cost of job 2 will be 75,000 now. Alright. So by definition, the opportunity cost is the value of the next best alternative foregone. That means what we are ready to leave, to forego in availing the best. So we are availing the best, which is 80,000 rupees, and we are foregoing the next best alternative, which is 75,000 rupees in this case. Alright. Let's understand this in terms of two goods. Let us say X and Y are two goods. If we want to increase the production of good X, then we will have to reduce the production of good Y. Or if you want to increase the production of good Y, we will have to reduce the production of good X. Why? Because we are talking of the assumption that the given resources are constant, the technology also does not change. Now graphically, if we want to increase the production of good X on the x-axis over here, then we have to reduce the production of good Y. So if you reduce the production of good Y, the graph slopes downward. That is what we saw when we plotted the production possibility curve. So this curve moves downward, and that was the first observation that we made, that a PPC is downward sloping. Why is it downward sloping? Because we are foregoing certain units of Y in order to increase the production of good X. At this point, Y is here, but X is just here. But if you look at this point over here, we find Y is down here, whereas X has increased to this point from here. See? So to increase the production of good X, we need to reduce the production of good Y, and that is why it is downward sloping. The second observation that we make is that it is concave to the origin. That means the shape of this PPC is concave to origin. This is the origin where you have a 0. Why is it concave to the origin? Because we are losing certain units of good Y to produce more units of good X. That means the marginal rate of transformation. What is marginal rate of transformation? We learned in assumptions that the resources can be shifted. So if you want to produce more of good X, we will shift the resources that we will use to produce good Y to produce good X. So the resources on Y will reduce and resources to produce X will increase. Hence, it is a concave shape. Let's understand this with the help of a numerical. Now, for example, we have two alternatives. That is wheat in kgs, production of wheat in kgs, or production of cloth in meters. Resources are given to us which are constant. The technology used is also constant, whether to produce wheat or whether to produce cloth. Now, if we choose to produce all wheat with the given resources, then we cannot produce any of the cloth. On the other hand, if we choose to produce all cloth, then we cannot produce any of wheat. Those are the two extreme conditions. However, if we want a combination of goods, then we will have to forego certain units of wheat to produce certain units of cloth. Now let us see how we are foregoing. We are foregoing 10 units of wheat to produce 25 units of cloth. In the second stage, we are foregoing 20 units of wheat to produce 25 more units of cloth. In the next stage, we are reducing the 70 to 40. So what is the difference? 30. So we are foregoing 30 units of wheat to produce 50 to 75. The difference is 25. So another 25 units of cloth can be produced when we forego 30 units of wheat. 40 minus 10 is again 30 units of wheat we are foregoing to produce 75 and 85. The difference is 10 units of cloth. Now 10 minus 0 is 10. So we are foregoing the rest, that is 10 units of wheat to produce 87 minus 85 is 2 units of cloth. So the opportunity cost at every stage is different. That means to produce every additional unit of cloth, we are foregoing certain units of wheat. Let us call this wheat Y because we are foregoing this, and X is cloth because we are increasing the production of cloth. Now, to produce an additional unit of X, we are foregoing certain units of Y. So, this additional unit will be called as marginal cost, or here in this case, marginal opportunity cost. How is it calculated? If it is on the total, then we will write opportunity cost is equal to Y by X, because Y we are foregoing divided by X we are gaining. Okay, now since this is marginal opportunity cost, it will be defined as the ratio of number of units of a good sacrificed. What is the number of units of good sacrificed? It is number of units of good Y to produce an additional unit of good X. So every additional unit of good X that we are producing, we are foregoing certain units of good Y. Okay, so this change in the number of units will be represented by delta. So how many units of Y did we forego to produce every additional unit of X? Will be given by the marginal opportunity cost equal to delta Y by delta X. Now for every stage, we will calculate this marginal opportunity cost and we will observe something. Okay, so here in the first stage, we do not have any marginal cost because we are ready to produce only wheat. We don't have a choice. Now in the second stage, we opt to have a combination of wheat and cloth. So here at this stage, how many units are we foregoing? We are foregoing 10 units of Y to produce 25 units of cloth. Similarly, in the second stage, we are foregoing 20 units of wheat for 25 units of cloth. Now here 30 units we are foregoing to produce another 25 units of cloth. Here at this stage, we are foregoing 30 units of wheat to produce 10 units of cloth. Now here in the last, we forego the rest of the 10 units to produce additional 2 units of cloth. Now let's calculate this. 10 by 25 is 0.4 and 20 by 25 will be 0.8 and 30 by 25 will be how much? 1.2 and 30 by 10 is equal to 3 and 10 by 2 is equal to 5. What is our observation? The observation is 0.4, 0.8, 1.2, 3 and 5. That means what? The marginal opportunity cost increases. The marginal opportunity cost keeps on increasing. Okay, this is one more reason why it is downward sloping. Now, if we plot this y and x on the graph, what do we find is, suppose we plot this good x on the x-axis and good y on the y-axis. Good y here is wheat and good x is cloth. Now, if we plot these on the graph, we find here is 0, 0 and 100, 0 and 100. Then we have 25 units of cloth to 90 units of wheat. So 25 is somewhere here, 25 and 90. Similarly, we have 50 and 70. So we have 50 and 70. And then we have 75 and 40. So 75 and 40. And then we have 85 and 10. So somewhere 85 and 10 over here. And when we join these points, you get this kind of a PPC, okay, which is concave to the origin, and also it is downward sloping because you start a graph from here, isn't it? So it is downward sloping. The last point is here. Now, let us observe this MOC, that is marginal opportunity cost. What is it given by? The marginal opportunity cost. That means this much of Y we have foregone to produce this much of X, isn't it? So here this will be called as delta Y and this will be called as delta X. So the marginal opportunity cost is given by delta Y by delta X. What is this delta Y? These are the units that we have foregone from 90 to 70. So this is equal to 20 divided by, how much is this equal to? This is equal to 25 units, isn't it? This is 25 to 50. So that is equal to 25 units. So again we are getting 0.8 over here. The first one will be over here, the second here. So this is otherwise called as marginal rate of transformation or the slope of PPC. The slope of PPC. So by formula, the marginal opportunity cost, which is also equal to marginal rate of transformation. What is marginal rate of transformation? Is we are transforming or transferring the resources to produce good X. So delta Y by delta X, which is also equal to loss of good Y divided by gain of good X. This should be gain of good X. Okay. So the ratio of the number of units of a good sacrificed to produce an additional unit of good X gives us the marginal opportunity cost.